Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode 3289, the two sneaky numbers of Digitville. The question is very interesting and also it has been asked in Google twice the last 6 months. Also it is marked as easy. Easy means it can be solved straightforwardly with a brute force, but it doesn't mean that a follow-up question is coming for this or they are just tightening the constraints. It will remain easy. So for the beginner, it might be a bit tricky question. And with the help of this question, I'm going to explain you a simple trick where we are just mapping every single number with the index itself in the same array. And this trick I have seen in a couple of problems on arrays. So let's dive in. And firstly, have a look on the problem statement. So in the town of Digitville, there was a list of numbers called nums. And nums containing the integers from 0 to n minus 1. Each number was supposed to be appear exactly once in the list. However, two mischievous numbers sneaked in an additional time. That is, two numbers are appearing 2 times in this list, apart from the other ones where they are appearing only once. And if two numbers are appearing 2 more times, so that it is going to make the list longer by 2. As the town detective, your task is to find those two sneaky numbers and return an array of size 2 containing those two numbers in any order to return the piece back to the Digitville. So this was the problem statement, and let me explain you in a simple term what is given to us and what is expected from us. We are given an integer array where all the integers in this array are going to belong from this range 0 to n minus 1. But two numbers are appearing 2 times. Let's say number A and number B are appearing 2 times. So list is plus 2. These are n numbers and 2 numbers are repeated. So the list will become n plus 2. So nums.length is n plus 2. And every number is going to belong from this range, also given in the constraints. First constraint is n is going from 2 to 100. Fourth one is the input is generated such that nums contain exactly 2 repeated elements. They are trying to say that input is valid. You just assume whatever is said to you. So whatever is given as part of problem statement, we have to just go according to that this is an array where every element is going to belong from this range apart from these 2 elements. So those 2 elements we have to return to the caller in any order. So that is our problem statement. The first thing that will come to everybody's mind is preparing the frequency map. And what is a frequency map? How many times any element is appearing in this array. So let's say I have taken a hash table data structure. Hash map is the implementation of hash table data structure in Java, and corresponding to other languages we have different implementation, but data structure is behind it is the hash table where we have a key and we have a value. In the key I'm going to store that value from this nums array, and the value is +1 +1. How many times the element is appearing in this array. I will iterate over this array from left to right and keep on adding those items in the frequency map. And at the end, I will see how many items are having frequency equal to 2. As we have input which is valid, so we will only be having 2 elements with a frequency of 2. And those 2 elements we have to return as a part of this process. So those 2 value, let's say value 1 and value 2. This is going to be my answer. So this approach is pretty simple. Taking a hash table data structure, taking a map and putting every single item in the map. If we just have a look on the time and space complexity. Time complexity is every single item I am visiting one by one. So order of one time operation. What is order of one time operation? Operation is putting that value in the map. So map dot put operation is order of one time. So I'm going to every single item and doing that operation, which is a constant time operation. So in total, I am having order of n, around order of n time operations. So linear time complexity. What about space? Every item is unique. Maybe we have around n elements, so definitely n entries will be there in the map. So order of n, space complexity, order of n, time complexity. So this is going to be our approach. We are not going into the detail of this approach. We can just have a for loop and add every single item in the map and get to this time and space complexity. Now the task is, whatever is going to be asked as a part of follow-up question in the interview, that how do we optimize it further? Firstly, we need to see, can we optimize the time complexity? No, because we are spending order of 1 time per item. We can't go better than this, and we have to visit every single item for sure. Okay, so order of 1 time per item. So it means time complexity we can approve, but we can have a look on the space complexity. Here in terms of space complexity, those constraints will come into picture. Every single item in this array is going to belong from this range 0 to n minus 1, and this array size is n plus 2. If the array size is n plus 2, how many what is the range of these indices? Indices will be from 0 to n plus 1. So 0 to n plus 1. So indices in this array is going to belong from 0 to n plus 1, both inclusive. And the item means any value on this index will belong to 0 to n minus 1, both inclusive. And the value is always greater than equal to 0. So to check whether an item is already visited or not, we can utilize the same array itself. So that is our trick. So I will explain you how. Ultimately, what we are doing is we are tracking it in a map. Tracking in a map means if an entry is coming for the first time, that is added in the map with a frequency of 0. When next time it is added in the map, it is already present in the map and we are just incrementing the frequency. So if it is already appeared in the map, it means that is our answer. So an item, if that item is already visited as a part of our iteration, it means that item is going to be the part of my answer. So when I am iterating over the array, I am checking 0. Okay, 0 is there, 3 is there, 2 is there, 1 is there. Again 3 is already visited. So 3 is the culprit. 3 is coming twice. 2 is already there. 2 is already visited. So 2 is going to be the part of my answer. Ultimately, we need to track the elements which are already visited as we do the traversal. So when we do the traversal, item will belong from this range. And how do we keep track of those items as visited? Simple approach, brute force approach is maintaining a set data structure, whether this item is already visited or not. This approach is quite similar to the previous one where I have taken a map, but here we need to do something better. Take the benefit of these two equations. If the element value is going to belong from this range, why not I just put another negative sign to identify that whether this item is already visited or not. When I am at ith index, I will just get the value of it. So this value, I will check this value as a index again. Multiply equal to -1. So this is something I can do. If it is getting confusing, I will just give you an example, show you by an example. So let's say this is my array, and in this array what are the indices? 0, 1, 2, 3, 4, 5. Elements are going to belong from 0 to 4. Now first item is 0. And the 0 index, if I just go and negate the value, it is going to cause me some trouble, because we cannot make the 0 negative. So let's ignore this for now. For 3, I can go to the third index and make it a negative value. If I make it a negative value, and again if I'm just going to going to 3, going to check the value present at 3, it will tell me that okay, this value is already visited. It means this 3 is already visited. I am coming to 3, I am marking 3 visited. I am coming to 2, I am marking 2 visited. When I am coming to 3, the value is 1. I am marking the value at 1 visited. When I am coming to 4, the value is 3. When I go to the third index is already negative. It means item 3 is being visited second time. So when I do the traversal, I have my value. Value is value present at this. And this value, I can map this value to index. Indices are 0 to n plus 1, because the size of this array is n plus 2. Mapping this value to this index, because value of x will belong to 0 to n minus 1. And I can easily map every single item from 0 to n minus 1 to 0 to n plus 1. Right? We have 2 extra elements. But the problem is the 0 is causing issues. If the 0 is causing issues, why it is causing issues? Because we cannot have a negative value, negative 0. If the 0 is causing issues, why not you just directly map 0 to something else? Or you can do one thing. In this array, every single item is going to belong from 0 to n minus 1. Remove this 0 and make the range from 1 to n by making every single 0 to n. An important part here. So if the 0 is causing the trouble, get rid with 0 by converting 0 to n. Why? Because n can easily be mapped in this array. So here from this array, if I just make 0 to n, n value is 4 here. So 4, 3, 2, 1, 3, 2. This will be my array, and indices are 0, 1, 2, 3, 4, 5. Now if I try to do the same approach, first element is 4. 4 means that I am mapping 4 to something else. Where should I map the 4? Instead of I have two options. As this array is going to be from 0, 1, 2 till n plus 1, I can map all the items from 1 to n here. Or what I can do is I can map all the items from 1 to n minus 1 and map this n to 0. Map this n to 0. How I can do that? It means that every single item is this, and the index I can get by taking modulus with n. So this is my item, and to map it to the relevant index, I can take a mod with n. So if I just do this for against every single value, values are now from 1 to n, and they will be mapped to 1 to n minus 1 and 0 index. So why I'm not mapping it to n plus 1 or n? Because in some cases we don't have that extra element. We have n size array and elements are n in number. So in those cases that 0 index should also be used. So that's why I'm talking in that way. So 4 is mapped to take the value of 4, take the modulus with the size of array, it is coming as 0. So make the 0 value negative. Let's move to the next element. I have 3. 3 means move to the third element. Third element is not negative. It means third element is being visited first time. And make the element at 3 negative. Come to 2. Move to the second index. This value is 2, move to the second index, make the second index negative. Coming to 3, the value is 1, move to the first index and make the value negative. Coming here, index 4, value is 3. Value is 3 means I will just move to the index 3 and I see that index 3 is already visited. If index 3 is already visited, it means that this 3 is coming second time. If it is coming second time, add it to the answer. Next item is 2. 2. Move to 2. 2 is also visited. So 2 is also coming second time. So in this way, we can get our answer. So this is our answer. Every single item going to belong from this range 0 to n minus 1. And I am mapping every single item to the typical index, converting 0 to n. So the range will become 1 to n. And here I am mapping every single item from index 1, item 1 to index 1, and item n to index n minus 1, and item n minus 1 to index n minus 1. Okay, let's say the n value is 4. So the items are 1, 2, 3, 4. So this is the values and indices that I have to map it to. Indexes are 0, 1, 2, 3. I am mapping 4 to 0 directly. So value taking modulus with n. And this value can also be negative. Maybe in the first time it is making as negative, and when I'm reading it, I will just take the modulus value. Why? Because elements are already positive. So I will take the modulus of this current value and I will take absolute value of this current value and take the modulus with n. So it will be my index. So this will give me the index, and I will just directly check if this index value is negative, this item is coming twice. If this index value is positive, this item is coming for the first time, and make it negative. So this is the approach. In this example, items are going to belong from 0 to n minus 1. So what is this n minus 1? Let's say length of this array is this. Then n value is length minus 2. So this is the n value, length minus 2. So here first of all I am replacing every single 0 to n. In this case length is equal to 4. So value of n is equal to 2. And indices are 0, 1, 2, 3. So I am replacing every single 0 to 2. If I do this, the array will become like this: 2, 1, 1, and 2. And these are the indices 0, 1, 2, 3. Now I will just iterate over the array again, iterate over the whole array. It should be length. Here we have length of the array. N is length minus 2. The main idea is that you understand this concept, that okay, mapping every single item to the particular index. So first item is take the absolute value of current value. Absolute value of current item is 2. Take the modulus with n. Modulus with n means n is 2. So it will come out as 0 index. So 0 index is not negative, so make it negative. This item is done. When I come to this item value is 1, and the index is also 1, and value at 1 is also not negative. So I will just perform this, make it negative. When I'm coming to this item value is 1, map to the corresponding index. Value is 1, go to the corresponding index. This index is negative. It means that 1 is repeating. 1 is repeating means add 1 to the answer. Coming to the fourth item, value is 2. 2 is mapped to index 0 because 2 modulus n. So this index will come out as 0, and this 0 index value is negative already. So 0 is also the answer. So 1, 0. So 1, 0 are repeating from the given input. So this is how we can do it in order of n time with order of 1 space by utilizing the same array size. Here it is just made easy because this array is of size n plus 2 and we are mapping items from 0 to n minus 1. So we have some extra block, so some edge case might get cancelled out, but yeah, this is the main intuition behind it. So I'll just show you the working code. We are taking the length of the array. The value of n is length minus 2. We know as a part of input, or in the constraint it's already given. Length is equal to n plus 2. Make all the value which are 0 to n, because 0 is going to cause trouble. 0 cannot be negative. After that, iterate over the array and check the index corresponding to every single item. Current element might be being visited second time, so it might be already negative. So take the modulus value and take modulus with n as well, because we are maintaining within the 0 to n minus 1 range. Corresponding index I got. If this index value is negative, this is the part of the answer. Otherwise, make it negative, marking it visited. That is the problem solution. Or I hope you have understood it. In case you have some doubt, you can just reach out to me in the comment section below or discuss in the Discord community. I'll be available there. Thanks for watching, guys. Bye bye.